This is AP Calculus, and we are on the first self-check for our entire class, self-check 1.1. So the way that you do this is you give yourself 10 minutes for 1.1 and do these problems. It will probably take you less time than that, but 10 minutes is the average that you should be looking for, because on the AP test, each multiple choice question should be taking you approximately 2 minutes, and there are 5 questions, 3 on the front, 2 on the back, for a total of 5. So give yourself 10 minutes, go, pause the video, and you've unpaused the video because you want to know the solutions. So here's a solution. Whenever you have a limit, the first step is just plug it in and see if it works. And I immediately see if I plug it in, -3, I'm going to get 0 on the bottom, but let's just do it really quick. -3 squared is going to be -3 quantity squared. I'll just write out my work so you can see what's going to happen. I'm going to add that to -3, then I'm subtracting 6. All that's going to be divided by -3 plus 3. -3 squared is 9. 9 minus 3 minus 6 is 0, and 0. This is called the indeterminate form. Indeterminate form means factor, cancel, plug in. That's just one of those flashcards, one of those things you have to have memorized. Factor, cancel, plug in. So I factor the top. I factor the top using Ninja Star. I'm using Ninja Star in my head, and I see that this is going to be x plus 3, x minus 2. X plus 3, x minus 2. All this is still divided by x plus 3. That was factoring. Now I cancel. It's pretty straightforward. What's going to cancel? And then I plug in again. When I plug in -3, -3 minus 2 is a -5. This is equal to now -5. The correct answer is B. On to number 2. I need to find a k so that f of x is continuous for all x. So if it's continuous, that means the left is equal to the right, which is equal to the actual height. In this case, since the left-hand side is the actual height, since there's an equal to here, all I'm doing is I'm setting the left equal to the right. I'm setting this equation equal to this equation while plugging in the suspect point 2 for wherever you see an x. So I'll write that out. I have x plus 3 is equal to kx plus 6, but I'm substituting 2 for x. So this is now going to be 5 is equal to 2k plus 6, and then I'm solving. Subtract 6 from both sides, I'm left with -1 is equal to 2k, and then from here divide both sides by 2, and I get negative, a little bit over here, -1/2 is equal to k. The correct answer here is A. Alright, moving on to number 3, limit to infinity. Flashcard, what is limit to infinity? You should immediately say horizontal asymptote, and that is correct. How do you actually do it though? Well, you only care about the biggest possible thing, the x squared. Everything else that's smaller, ignore it, ignore it, ignore it, ignore it, ignore it. I only care about these two terms. Well, when I plug in infinity, I'm only looking at the biggest term, so what does that look like? I'm literally canceling out the x squared. I'm dividing the top and bottom by x squared, which means now this x squared and this x squared are gone, and it's just 5/4. Another way of thinking about this is just, it's a magic fraction. The top power here and the bottom power are the same. This is the case where you have top divided by bottom, instead of having, for example, top divided by bottom. So if I have big top divided by bottom, that's D and E. If it's small top divided by big bottom, that's 0. This one is top divided by bottom, which is magic fraction. Magic fraction, of course, is just take the coefficients, 5/4. 5/4 is D. That is our final answer. Moving on to number 4. Which of the following does the limit as x goes to 3 from both sides of f of x exist? Circle our answer. So both sides to 3. Well, if I look at A, if I go from the left, I go to negative infinity. If I go from the right, it goes to positive infinity. That one does not exist. The limit as I go to 3, again, it doesn't matter what happens at 3, this one is a whole, but it matters what happens as I get closer and closer to that electric fence, I guess is what we use the analogy. So as I get closer and closer, I get closer and closer to a height of 3 from the left. So I get closer and closer to a height of 3, get closer and closer to a height of 3. The answer here is actually B. That is correct. I don't care what happens at the point 3. It could be a hole, it could be a point down here. It doesn't really matter, but as I get closer and closer and closer, I do get closer to a height of 3. I get closer and closer and closer to a height of 3. Let's look at what these other ones, why they don't work. As I go from the left, I get closer and closer and closer to a height of 3, which works, but I get closer and closer and closer to a height of 1 from the right. So the double-sided limit does not exist. And over here, I get closer and closer and closer to a height of 3 from the left. There's nothing on the right. The right one does not exist. So it can't be C, can't be D. The correct answer was B. And the last problem, which of the following is true for the value of the limit as x approaches 4 from both sides of f of x? All right, well, as I go from the left, I get closer and closer to a height of 2. So from the left, 2, from the right, I get closer and closer and closer to a height of 6. Well, if they're not the same number, it's a D and E. That's the answer, E, D and E. That's all I have, so I think you're going to be working on self-check 1.2 now. So again, give yourself 10 minutes. It's another 5 problems, I believe. 1, 2, 3, 4, 5. Yep. 10 minutes on the clock, and go. Alright, so you pause the video now, you unpause the video now, and you're ready to go through the answers. So, limit as x goes to 0. You can see immediately when you plug in 0, it's going to be 0, 0, 0, 0. You're going to have the indeterminate form 0 over 0, which means I do 3 things. Whenever you have indeterminate form, that's right, factor, cancel, plug in. So, factor this thing. X squared is the biggest thing I can pull out. X squared times 3x squared plus 2. And I can factor an x squared on the bottom as well. X squared and 6x to the power of 3 plus 5. All right, factor, cancel, plug in. I need to now cancel. Cancel, cancel. All right, and finally plug in. Plug in the 0. When I plug in 0, you can see what's going to happen. This is going to be 0. This is going to be 0. The answer is 2/5. The correct answer is C, 2/5. Moving on to number 2. We have this cool graph, and we need to figure out which of these is true, which means many of them are false. This is saying the limit as x approaches a from both sides of f of x. Let's first figure out this left-hand side. As I go closer and closer to a from both sides, on the left, I get closer and closer to a height of 2. From the right, I get closer and closer to a height of 2. Let's write that down. This one is 2. If they're different numbers, it would be d and e, and you can't even do anything. You can't have d and e equals to d and e. Okay, let's check out this one. Limit as of f of x as x approaches b from both sides. So from the right, I have 1. From the left, I have 2. Since those are 2 different values, that one is d and e. 2 cannot equal d and e. It's not a. Let's try this one. Limit of f of x as x approaches a from both sides. We already figured out that was 2. 2 equals 2, the answer is B. Let's go through the rest of them and figure out why they're not true. The limit of f of x as x approaches b from both sides, we know that that's d and e. We already went through it. D and e cannot equal 1, can't be C. D, we know that this is also a d and e. D and e cannot equal 2, that's not true. The limit of f of x as x approaches a from both sides does not exist. It does exist, and it is 2. This one is actually 2, so if it is a number, it does exist. If it was a d and e, it obviously is d and e. It does not exist, so that one is also not true. The correct answer is B. Moving on to number 3. X approaches infinity. The limit as x approaches infinity, that is a flashcard that you need to know. That is finding that's right, the horizontal asymptote. So when I do that, I'm using my top-bottom rules. So ignore all the small things. Ignore all the small things. And this is a case where I have small top, big bottom. B-O-T-T-O-M. That immediately turns into 0. D. All right, moving on to number 4. For what values of k is the function continuous at x equals 5? Okay, this is the continuity test. Continuity test states that the left is equal to the right, which is equal to the actual height. Actual height. But in this case, it's saying that the left piece here is the actual height because there's an equal to sign here. So that's saying that this left and this actual height are the same thing. So I'm really not caring about the actual height. I can just do left equal to right. So left equal to right, plugging in the suspect point, and I'll find the value of k that works. So if I come over here, I'm going to say 2, and I'm going to plug in immediately. So this was going to be x squared, but it's now going to be 5 quantity squared minus 5 times 5 minus 4. I just copied down this equation but plugged in our suspect point 5 for x. Now this needs to be equal to the right. The right piece is kx squared, or k times, in parentheses, 5 squared. That is our suspect point, plugging in, plus 5. Alright, we've plugged in everything. We set the left equal to right using the continuity test, and from here I just need to solve for k. So 5 squared is 25, times 2 is 50, minus 5 times 5 is 25, minus 4 is equal to 5 squared is 25k plus 5. All right, I'm going to leave the k's on the right, move the 5 on over. So if I have 50 minus 25, that is going to be 25. 25 minus 4 is 21. Subtract 5 again, and that is going to be 16 is equal to 25k. And then from there, divide both sides by 25, and I'm left with 16 divided by 25 is equal to k. Final answer, 16 over 25. There it is. Correct answer is C. Moving on to number 5. Ooh, really cool graph here for between -2 and 2. So from here to here, f prime does not exist for x is equal to what? So notice that it's not equal to 2. Of course, this is a sharp corner, but that is not included in the answer because it's not equal to, although I really want to include a 2 here. All right, so where do you have f prime dne in general? There's 3 things. 1, 2, 3. You have to have these memorized. Where does f prime dne? That's right, where it's not continuous, at sharp corners, and finally, vertical tangents. And what are the 4 things that will make it not continuous? 1, 2, 3, 4. Holes, gaps, I can't spell gaps, ends, and VAs. All of these things need to be memorized. All right, so these are the things we're looking for. All 4 of these, sharp corners and vertical tangents, any of those will make it DNE. Okay, we have a hole here at 1, so 1 is definitely included. We have a gap and a vertical asymptote here at 0, so that is also included. And we have another gap at -1, so all 3 of those are the answers. All 3 of them, D is the final answer. And that concludes Self-Check 1.2. On Monday, no, not Monday, we have a 3-day weekend, so on Tuesday we're going to come back and we're going to do Self-Check 1.3 and 1.4. These are the problems that are going to prepare you for the pre-test, which will prepare you for the actual test. So you have lots and lots of practice before you take the test, which you cannot retake. I hope you guys have a good 3-day weekend. I will see you on Tuesday.